good afternoon everyone. In this video I'll talk to you guys about histograms. So another possibility for showing the distributions is to use a histogram. A histogram looks similar to the bar chart, but there's no spaces between the bars. So in the bar chart, if you've noticed, there are categories that defines the number of bars, and there's spaces in between the bars. But over here, even though the marks that we use are bars, but there's no spaces in between the marks. So a standardized test, auditors, for example, looking for evidence of grade tempering, might construct a histogram like this of the students' scores. Typically, a normal distribution will look something like this. The test scores are shown on the x-axis, and the height of each bar here is the number of students that scored, for example, here 30, scored 34. So it is frequencies. So it is here the certain numbers, scores, and the bars or the height of the bars indicates the frequencies or the number of students. It's an aggregation of the sum. A typical distribution should have a fairly recognizable bell curve, which is like a normal distribution, with some students doing poorly, some doing extremely well, and most of the students expected to fall into the average. This is another histogram, as you can see. This histogram shows that there's no bell curve. We can see that here we have failing students, but then all of a sudden most of the students here there's a surge here. So probably if it was normal, it should these little bars over here are supposed to be a continuation of the failing students. So this is when you probably drive or draw a curve or shift some grades, some students' grades, and add certain number of grades for students falling in a certain range, and then most of them will be just on the edge of the passing grade, and then this will show that the distribution is not normal. Maybe it has been tampered with. Okay, so something is clearly wrong here. Perhaps the graders have pumped up students who were just shy of passing to barely passing. So it's also possible this may indicate bias in subjective grading instead of blatant tempering. And we shouldn't just jump into the conclusions, but the pattern is not a normal distribution and requires certain investigation. So whenever your pattern looks like this, you need to explain why it is looking like this. So how do we create a histogram? And this example of, that we have of the hospital data, we would like to take a look at what time is it? A histogram of the time it takes to begin patient treatment. And let's go ahead and take a look at this histogram that I've just created before the video. So over here you can see that you have a measure, which is the minutes to service. And these minutes to service here are the different bins that we have. Sorry, not the bins. These are the minutes to service on the axes. Now, count of minutes to service. Why count? Because we want the frequencies, as I just explained earlier. It's about the number of minutes to service, the count of minutes to service. So the count of minutes to service, meaning here how many times the minutes to service were from 0 to 5. So basically it is how many patients, in fact, their minutes to service was 0 to 5, or 5 to what's the pin here? The pin is, it's very difficult to read the pin also, can't you see? So this is 0 to So minutes to service bin is 6.5. So they show you the 6.5. So it's not 0 to 5, it's 0 to 6.5. And here is 6.52. Another 6.5 will be about 13. Yeah, and so on. Okay. So here's 0, here starting from 6.5, and then he's starting from 13, and then from 19.5, and so on. Good, good, good. So from 0 to 6.5. Now, before we technically talk about how to construct a histogram, let's talk a little bit about the size of the bin. Why is the size of the bin 6.5? So there is a standard way that softwares use to compute the size of the bins. However, statistically, there's also different ways of computing the size of the bins. For example, one of the ways that I personally use is the 2 times the IQR. Do you remember from the previous video we talked about the internal quartiles? So you multiply the inner quartiles, not internal, inner quartiles, multiply them by 2, and then multiply that by the number of data points raised to the power of -1/3. Yeah, so this is the rule that this rule is called the Friedman Diaconus rule. So once you use this rule, you get the inner quartile value, and you have the number of points. If you use this formula, which is 2 times the inner quartiles multiplied by n to the power of -1/3, then you will get an approximate number of bins. So you divide the number of data points on that, and you will get the size of the bin. Other rules are Rice's rule, there's a Scott's rule. So there are different kind of rules, and every rule will give you a different, not necessarily very far off of a bin size, but it may give you a different reading. So it depends. So if you're questioning why the number of bins is this way, or why can I tamper with the number of bins, for example, you could actually edit the, let me just recreate the chart first, and then show you that you can edit the chart altogether. So let's take the minutes to service. So this is the columns. Here are the different minutes to service. And then we take the minutes to service as count. So let's put it as count, and then let's make sure that it is in bars, and over here which aggregation. This is the question. This is a very important question. So we need to make sure that this is minutes to service and one is account. So even though this is minutes to service, I think we need to put it as discrete. And this is the count. And the histogram is not discrete, no. Man. So I will give you a minute. Please hold the video here. Stop my video and figure out what the x-axis here is supposed to be. Of course, it's not a minimum. So what is it supposed to be? The aggregation here. Well, it's supposed to be an average, a median, a maximum, minimum. What is it supposed to be? And get back to me. Okay, so I hope that you took some time to find out um, which format here you would like to get. In fact, I would like to start all over again. So let's get rid of everything and let's put minutes to service and put it as count, and then just add a distribution here, a histogram. So probably you tried most of the aggregation and you got frustrated. You couldn't find out what the problem could be, and there's no problem with you. I'm sorry, I didn't my intention was not to get you frustrated. It's just the first time we actually get one field of data, one field only, and create a whole a chart or visualization based on it. So you take the minutes to service, you put it on rows, and these are supposed to be counts. So you put a histogram, and then it is all automated for you. So if you notice right now, I didn't have to even put the count. So this is one interesting question that you might get in the certification. So how do you create a histogram? You just drag whatever the measure is here, minutes to service. Do not alter anything with the aggregation. You might think that you need to alter anything with the aggregation. You don't. Just go to show me and just put a histogram. As easy as it is. Isn't this awesome? Now, this is a very awesome, easy way. Here you can format. You can format with the rows, columns, but I actually would like to edit the histogram, or edit the pins of the histogram. So let's see edit axes here. So here, edit axes, you can see that you can do a uniform axis range, you can do logarithmic scale if you want, but we don't need a logarithmic scale here because we don't have two different data types and there's a huge gap in between them. So if you are plotting, for example, revenues, and revenues are in million yen, and then the number of customers or clients, let's say, because usually clients are less than customers, so the number of clients is in maximum 2 digits to 3 digits, like 100 clients are responsible for millions of yens. There's a big gap between the two readings, and your intention is to plot two different data curves or two different data types within the same plot. In this case, if you're using and they're both sharing the same vertical axes, what's going to happen is one curve will be almost showing no behavior and almost not even showing much in the visualization, and the other is shooting up. So there is no consistency. For this purpose, we resort to logarithmic scale transformation. With logarithmic scale transformation, we can see at least the behavior of both curves. Now let's take a look and see how do you edit the number of bins. So how do you edit the bins? In the case of the histogram that you created earlier, the size was set to 6.5 minutes. This may not be the most helpful for understanding the data in case. So you might wish to edit the size by right-clicking the minutes to service bin field under the dimensions in the data pane, and select edit, and then adjust the size to something more intuitive, such as 5. In fact, this explanation is not really great, but the explanation that I've just given you earlier, that there are certain rules that you could follow to guide you through the number of bins, or the size, actually, the size of a bin. This will help you. So over here you can format the axes, but I actually myself minutes to service. Apparently you go to minutes to service, and then here. One more thing I wanted to get your attention to is that when you are creating a histogram, first thing we established that creating a histogram, you just drag and drop one measure. You don't tamper whatsoever with the aggregation. You just leave it there. And then you go to show me and you create a histogram. What happens is that immediately you get a histogram. Immediately you get a histogram like this. And you will get, as you can see here, do you see here, it's like a normal distribution, a bill curve, minutes to service bin. And over here you can edit the number of bins. So instead of 6 you can put it as 5, or here is the suggested bin size based on their calculations. Let's say you have a different, you're following a different rule. So this is the maximum, this is the difference is 108, this is, and so all the count, and you can see that the number of bins actually shows you how the number of bins could affect, in fact, the normality. Oh, sorry, I don't know what happened. So let's put the number of bins being, let me show you how you can actually manipulate the data. So here the bin is quite big. Here, edit, let's put it as 2. It's a little bit more normal now. You see that it's 2. Put it as 1 and you can claim more and more normal distribution. But is this good? Yeah, it's good for you if you are talking to idiots, honestly. If you're talking to idiots and you show the normal, and they trust you. Also, if you're talking to people that trust you, they trust that you made the calculations and you based the size of the bins on scientific calculations. Not because you want to show that you can use a certain technique in analytics and you want to show that the distribution is normal. So you go directly to Tableau and very quickly alter the number of the size of the bin, and then you can easily, or you can more likely claim a kind of normal distribution somehow. So hopefully people will be, you will be trustworthy and you won't do that, and hopefully you will base your number of bins at least based on the suggested bin method, bin size method that the software is using, or by doing the right thing also and investigating the either the Friedman Diaconis test or the Rice's rule, sorry, not test, rule, or the Rice's rule or the Scott's rule, so that you can base the size of the bin on an established rule. Okay, so what's next? Visualizing with multiple axes to compare different measures. We're going to talk about the scatter plot and the dual axes and combination charts in the next video. I'm going to have to check the minutes, the total minutes that I recorded so far, and based on that I will check if I am going to have to make one more video or not. In fact, I am already speaking for 19 minutes. I think this is it for today. So maybe next time I'm gonna just finalize everything with the scatter plot and dual axes, and I'm gonna start with the table calculations with you guys for next class. As for now, I would like you to submit an assignment where you have the following, and I'm gonna type in detail. I would like you to create the circle before jittering, the circle plot before jittering, and then the circle plot with jittering, and please fix the jitter so that it shows the vertical here, the vertical it's up to you. You want to show the axes, show it. You don't want to show it, don't show it. If you don't want to show it, don't show it. It's okay. I can still tell if you have figured out how to spread the values vertically. Then would like you to kindly create a box plot, and finally reproduce this histogram. And this is it for the assignment. So you will have 1, 2, 3, 4. 2 for the circle, 1 for the box, and 1 for the histogram. Thank you so much, guys, and enjoy your weekend. I'll see you again on Tuesday.